Hello, welcome to m253, Calculus 3 here at Cañada College. My name is Lapuz. We are in section 4.2 and this is checkpoint 4.6. They want us to evaluate the following limits as x, y approaches 5, negative 2 of the square root of x squared minus y in the numerator divided by y squared plus x minus 1 in the denominator. Now, the functions that are involved here are all continuous in its domains, and we really need to worry about something happening when the denominator is equal to 0. So, or if we have a negative under a square root. If we put 5 in for x and negative 2 in for y, we would get a 4 plus 5, which is 9 minus 1 is 8. So I think we'll be fine, and therefore we can use the limit laws. And we'll explicitly say that we're using limit laws. And really we just plug in the values, but let's be specific about it. So the limit as xy approaches 5, negative 2 of this quantity, we have x squared minus y in the numerator and y squared plus x minus 1 in the denominator. Really, we'll just be taking the limit of each of them. And the way I'm going to write it is just I'm going to break it down, because when we take the limit of just the x squared, then it's really just the x involved. So I'll say this is equal to limit as x approaches 5 of x squared. That's the first term. And we'll take the limit as y approaches negative 2 for this second term. And this is all over. Let's extend this. We have the limit as y approaches negative 2 of y squared plus limit as x approaches 5 of x minus 1. And so there's no variables there. And we'll just leave it as 1. So each of these are quantities that we're going to take limits. And again, I did a little shortcut, and since we're looking at it one variable at a time, we're just going to focus on like x going to 5 and y going to 2, negative 2 separately. All right, what do we have now? We have 5 squared, so that's 25 minus negative 2, and in the denominator we have 2 squared, negative 2 squared, plus this is just x, so that's just 5, and then minus 1. So it looks like square root of 27 over 8. And not much else you can do to simplify that, so we'll just leave it at that. Okay, I hope that helps.